When traffic is affected by construction, maintenance, or utility operations, traffic control is needed to safely guide and protect motorists, pedestrians, and workers in and through work zones. This zone is the area between the first advance warning sign and the point beyond the work where traffic is no longer affected. Most traffic control zones can be divided into 5 areas. In this part of the training, we'll look at each of the areas and examine them for one direction of travel. If the work you'll be doing affects more than one direction of travel, the same principles we cover here will apply to traffic in all directions. These are the 5 areas of traffic control we'll be discussing. Accidents can occur in all of these areas if they're not properly controlled. Advance warning area, transition area, buffer space, work area, and termination area. The advance warning area prepares drivers and alerts them to what's coming. An advance warning area is necessary for all traffic control zones because drivers need to know what to expect. Before reaching the work area, drivers should have enough time to adjust their driving patterns. In the advance warning area, traffic control devices may vary from a series of signs starting a mile in advance of the work area to a single sign or flashing lights on a vehicle. The advance warning area, from the first sign to the start of the transition area, should be long enough to give the motorist enough time to respond to the control devices. For most operations, the length can be 1 mile for freeways or expressways, 1,500 feet for most other roadways or open highway conditions, or 1 block or more for urban streets. Next is the transition area. When work is performed within 1 or more traveled lanes, a lane closure is generally required. In the transition area, traffic is channeled from the normal highway lanes to a new path, which is required to move traffic around the work area. Most often, this is accomplished with tapers to close the lanes. The transition area should be obvious to drivers. The correct path should be clearly marked with channelizing devices so the drivers will not make a mistake and follow the old path. If the existing pavement markings create confusion, temporary markings should be used. A taper is a series of channelizing devices placed at an angle to move traffic out of its normal path. There are 5 general types of tapers used in traffic control zones. Merging tapers close a lane of moving traffic on multi-lane highways where a merge is required. The spacing for channelizing devices should not be greater than the speed limit. Lane shift tapers move traffic to a different lane where a merge is not required. Shoulder closure tapers are needed to close shoulder areas. Two-way tapers control two-way traffic where drivers are required to alternately use a single lane. These tapers are used when flaggers are present. Downstream tapers are those installed to allow traffic back into the normal path. The length of each type of taper is very important and is determined by several factors. Let's look at each of these factors in more detail. The length of a merging taper, which is used to close a lane, is determined by the speed of traffic and the width of the lane to be closed. The 2 formulas for determining the length of tapers for lane closures are discussed in the Manual on Uniform Traffic Control Devices. For speeds of 45 miles an hour or greater, the merging taper length should be at least the width of the lane multiplied by the speed limit. For speeds of 40 miles an hour or less, the length of the taper should be at least the product of the width of the lane times the speed limit times the speed limit divided by 60. This is actually the high-speed taper multiplied by the speed limit divided by 60. In most tables, the equation goes this. Most state and local manuals include tables showing the required taper lengths for various speeds and lane widths. For example, a 40-mile-per-hour speed limit and an 11-foot lane requires a 295-foot merging taper. The lane shift taper is used when traffic is only being shifted and no merge is required. Therefore, the taper does not have to be as long as a merging taper. The minimum taper length is 1/2 L, where L is the computed length of a merging taper for the given speed limit and width of the lane shift. When an improved shoulder, having a width of 8 feet or more, is closed on a high-speed roadway, it should be treated as a closed part of the roadway. The shoulder taper should be 1/3 L, where L is the shoulder width multiplied by the speed limit. If the shoulder is used as a travel lane, however, the taper is equal to L. The two-way traffic taper is used in advance of a work area that occupies part of a two-way road when the remainder of the road is used alternately by traffic in either direction. A short taper is used to slow down traffic by giving the appearance of restricted alignment. One or more flaggers or temporary traffic signals are used to assign the right-of-way in such conditions. Two-way traffic tapers should be a maximum of 100 feet long, with channelizing devices spaced at a maximum of 20 feet to provide clear delineation of the taper. A downstream taper is used at the downstream end of the work to allow drivers back into the lane that was closed. It's placed in the termination area. While closing tapers are optional, they may be useful in smoothing traffic flow. However, they may not be advisable when material trucks move into the work area by backing up from the downstream end. If a closing taper is used, it should be at least 100 feet in length per lane. Here is a table from the Manual on Uniform Traffic Control Devices that shows the lengths for the 5 types of tapers. Let's briefly review tapers and taper lengths. Where traffic on a multi-lane highway must merge, the required length is the function of the speed limit and the lane width. If traffic on a multi-lane road is to be shifted to a different lane, the taper is 1/2 the length of the merging taper length. When working on an improved shoulder, the required taper length is 1/3 of the merging taper length. Now, when traffic is on a two-way road and it's reduced to one lane, a taper with a maximum length of 100 feet is needed. And to let the driver know that he may return to the closed portion of the roadway, a 100-foot taper may be used. If restricted sight distance is a problem, for example, a sharp vertical or horizontal curve, the taper should be moved well in advance of the obstructed view. Beginnings of tapers should never be hidden behind curves. Traffic should be observed to see if the taper is working correctly. Frequent use of brakes and evidence of skid markings are indications that either the taper is too short or the advance warning is inadequate. The buffer space is the open or unoccupied space between the transition and work area. The buffer space provides a margin of safety for both traffic and workers. If a driver doesn't see the advance warning devices or fails to negotiate the transition, a buffer space provides room to stop the vehicle before actually entering the work area. The length of the buffer space is based on the stopping sight distance for the speed being considered. The table shows the length of the buffer space for various speeds. This will provide adequate distance to allow the vehicle to stop before entering the work area. The length of the buffer area is measured from the end of the transition area. It is important for the buffer space to be free of equipment, workers, materials, and vehicles. When designing work zones, the following should be considered for buffer spaces. Place channelizing devices along the edge of the buffer space. The spacing should be no greater than twice the speed limit. Situations occur where one lane of traffic uses a lane that normally flows in the opposite direction. In these situations, a buffer space should be used to separate the two tapers for opposing directions of traffic to help prevent head-on collisions. The work area is that portion of the roadway which contains the work activity and is closed to traffic and set aside for exclusive work by workers, equipment, and construction materials. Work areas may remain in a fixed location or move as work progresses. The work area is usually delineated by channelizing devices or shielded by barriers to exclude traffic and pedestrians. Every feasible effort should be made to minimize traffic conflicts with the work area. These are suggestions. Use traffic control devices to make the travel path clearly visible to drivers. For nighttime operations, the traffic control devices must be retroreflectorized and have a large surface area. Place channelizing devices between the work area and the traveled way. Provide safe entrances and exits for work vehicles. Flags and flashing lights should be considered on work vehicles exposed to traffic, and a truck-mounted attenuator be provided whenever possible to protect work crews. The termination area provides a short distance for traffic to clear the work area and to return to the normal traffic lane. It extends from the downstream end of the work area to the end construction or end roadwork sign. A downstream taper may be placed in the termination area. For some work operations, such as single location utility or maintenance repair, it may not be necessary to display an in construction sign because it will be obvious to the drivers that they've passed the work area. Avoid gaps in the traffic controlled at work zones that may falsely indicate to drivers that they've passed the work area. For example, if the work includes intermittent activity through a 1-mile section, drivers should be reminded periodically that they are still in the work zone. The primary purpose of the guide sign, Road Construction Next Miles, is to inform the driver of the length of the work area. It should not be erected until work begins. In moving operations, the advance warning area may be provided by signs and flashing lights on the work vehicle. Additional advance warning signs may be warranted depending on the volume and the speed of traffic. A shadow vehicle equipped with an arrow panel sign and flashing lights may also be used. With moving operations, the transition area actually moves with the work area, and the buffer space is the area between the shadow vehicle, if one is used, and the work vehicle. The termination area is usually obvious to the driver passing the work vehicle. The use of a truck-mounted attenuator should be considered for moving operations. Now, as a review, these are the 5 parts of a traffic control zone. The advance warning area alerts the driver that there's something ahead that demands his close attention. In the transition area, traffic is shifted or moved to eliminate interference with work activities. The length of the taper should be computed or obtained from a table. The buffer area provides a margin of safety in case a vehicle runs through the transition area. The work area is for workers, equipment, and vehicles. The objective is to keep traffic out of this area. And the termination area tells motorists they're out of the construction area and may resume normal driving. This concludes the review of the 5 basic parts of a traffic control zone and their function. In the next session of the series, we'll be reviewing some typical applications that you'll be using in your work.